Hello and welcome to this episode of T-Tech. This is part 2 of 3 in our NetBSD Firewall series. I do hope you enjoy it, and let's get into it. Okay, welcome back. This is part 2 of 3 in our NetBSD Firewall series. And in this part here, we're on NetBSD, and we're going to start setting all those things up. So the first thing we want to do is log in as root real quick. And what I want to do first is show you what the LAN interface is and what the WAN interface is in this case. So to do this, we're going to do ifconfig. And in my case, WM1 I know is my WAN interface. Okay? And in here, WM0 is my LAN. So those are what we have to keep in mind when we're configuring this stuff. So the first thing we want to do is go use Vi, which is a text editor, and we want to go to etc rc.conf. Alright, this is where everything is configured in NetBSD. Now normally after you install, you will get something like this with DHCP, and this will automatically get you an address and a default gateway. If you have DHCP on your WAN, and you're not paying extra for a static IP address or anything like that, just make sure that in the flags section you put the right interface name. Alright, but in our case though, excuse me, I didn't use DHCP. So what you would do in this case is we're going to use a comment, okay, or number sign or hashtag, whatever you want to call it. Comment those out, and we're going to open a new line above that. So we're going to hold shift down and tap the O key. Okay, so the first thing is we want to configure our LAN. So we're going to do ifconfig _ WM0 equals, and then in quotes we want to put init. This specifies it's an IPv4 address, and if you want to do IPv6 it would be a init6, but we're focusing on IPv4 here. We're going to use 192.168.1.1 with a net mask of a /24, and then end the wrap it in another quote. So the thing is with the net mask, real quick so you understand why we have to do it this way, is each of these sections is 8 bits. Okay, so the 192 is 8 bits, and that's binary, so it's ones and zeros. Okay, and all these 3 sections together is 32 bits, and these sections in the net mask are those same bits. What this means basically is that when they're all on and they're ones, we add something called the bit values, and they add up to 255. Okay, when you have 255, 255, 255, and then a 0, this means the first 3 sections of your IPv4 address can't change, and they specify the network, or the street, in other words. And the 0 here means the last 8 bits can change, and we can assign those to computers on this network or street, or you can think of them like houses on a street. So this last section, 1, is one of those. It is one of the available addresses on this network. Hope that made sense, but basically once we put the other one in, you'll see what I mean. So the next thing is we're going to configure our WAN. That's WM1, and then that was 192.168.0.25 with a network mask of 24. And then since we're not using DHCP, we won't get a default gateway. So we have to put default route equals and specify our default gateway. And mine happens to be that. If you have a static IP, just put whatever they gave you there. But what I meant here is, you see how we had the up to the 3rd section? Well, this is 192.168.1, and this is 192.168.0. So there's two different networks. That's how it can route between them and understand. Alright, and that's the default gateway for it. Again, you don't need to put that if you use DHCP. Now, a few more things we have to do. We are going to want a DHCP server on our LAN, so we need to put DHCPD equals, and then yes in all caps. We need a firewall, so we're going to use the PF packet filter in this case. PF equals yes. And there's also a few things we want to disable. We're going to disable postfix, so postfix equals no. We're going to disable initd, no. And postfix is a mail relay agent, but it's also for logging. But basically what you need to know is we don't need to have that in this case. Okay, you can go on netbsd.org and read all about this stuff, but we do not need these programs running in this case. Okay, that's the main stuff we need in the rc.conf file. Now, there's three more things to do. We need to configure the DHCP server here, our PF rule set, and we need to enable IP routing. So we're going to hold Shift and tap Z twice. That saves our file for us. You know what? There was one more thing we should put in there. We should put a host name, shouldn't we? So we're going to put host name equals, and then I'm going to put FW for firewall. You can put whatever you want. Okay, and if you don't want to reboot, just etcrc.d. Oops. Actually, it's not that. We'll reboot when we're done here. But that specifies the host name. Okay, let's enable the IP routing next. So we're going to do etc sysctl.conf. At the bottom of this file, let's put net.init.ip.forwarding equals 1. Okay, the thing is, if you don't put this, what a router does is forward packets that aren't sourced from itself. So it doesn't have the IPs assigned to it. But with this on, it will not just ignore those packets. Like your computer would ignore packets that aren't from itself. But because we turned this on, it will forward them. Okay, save that the same way. Okay, now let's do the DHCP server. So etc dhcpd.conf. We're going to do option domain-name, then in quotes. We'll just put home here. You can put whatever you want, really. But end that with a semicolon. And under that, we do need to put domain name servers. These tell our clients, where to go for DNS queries. We're going to put 4221, a comma, space 4222. You can put whatever you want there as well, as long as they could be internal ones you have yourself or out on the internet, doesn't matter. We're going to put subnet, and this is the subnet to listen on for DHCP, and this is our LAN network. So we're going to specify the same thing we specified for the LAN interface. Now in here, we're going to open up a curly brace here, enter down a couple times, and I prefer to tab in, but that's just me. Now we're going to type range, space, 192.168.1.100. Whoops, forgot a 1 there. And 1.200, and that with a semicolon. This is the range of addresses our DHCP server will allow clients to lease. Okay, under that, we're going to say option routers, 192.168.1.1, and this is the default gateway that everyone on our LAN will use to get out to the internet. Okay, to close that block, we're going to use a matching curly brace at the bottom. Now we want to escape and then save the file the same way, but we do have to test this, so we're going to do dhcpd-t. Okay, because it came back and the config file is the one we just made, that means there was no errors in the file. Okay, but if you miss something like a semicolon or you don't say option, it'll tell you that. You can just go in and fix it. Alright, so that is configured, and that's how it looks when it's correct. Now, we need to configure our packet filter next. So what we want to do for that is copy with the cp command, pf etcpfconf, which is the stock one that comes with NetBSD. Let's make a backup of that. So we got a place to roll back to if we make a mistake. We'll remove the original and create a new one. First thing we want to do is make some macros. So the macros are variables, and they can hold information like an envelope. They can hold IP addresses, they can hold port numbers, they can hold interfaces. So what we need is LAN, because we want to have one for our LAN interface. WM0, and then we're going to close the quote. Of course, we want one for our WAN, and we want to put the right interface in. After we've done that, we can refer to them in a second. Now, we need to set runtime options to tell PF certain things we want it to do. So I want to say set skip on LO0. The set skip tells it to just ignore packets on that interface. The loopback is used for testing your TCP/IP stack, and it's also used for your router IDs in OSPF and EIGRP and things like that. We don't need to filter packets on that interface most times. Okay, next we're going to say set block -policy drop. Now this tells it what it should do when it drops a packet. Normally, if you don't set this, it's usually set to reject. Or if you don't have a firewall at all, it sends a reply back. That's what's supposed to happen. The thing is, it can be things like an ICMP port unreachable message, or if you reject the traffic with a block rule, it can actually be an ICMP administratively prohibited. Either of those sends information back to whoever is sending us the traffic, and it actually puts a load on our firewall that we don't want. So, general rule of thumb, I keep it to drop. You can use reject if you want, but keep it to drop in my opinion. Okay, first thing we actually want to do is do that network address translation. We're going to say nat on, so we're going to utilize that macro of WAN up there. From is going to say the source. So the source is LAN, but we're going to say :network. And this is, it will dynamically, something called expansion. When this loads, it will just put in whatever network is on the LAN interface. And so we don't have to type the network in, and then later, if we put 50 rules in here, come back in and have to change every one of them. So from that though, we want to say this traffic can go to any destination. And then we want to say hyphen, then a bracket, and in parentheses we want to specify the WAN macro. And the parentheses, these are helpful if you have DHCP and your IP changes. If the IP changes, it will start to change the source to the new IP, and you won't have to change anything on your end. So that was just the NAT. Remember, NAT's not security. The security is coming up right now. First thing we're going to say is block, drop, all. And before we go further, remember, PF processes packets from top to bottom, and every rule a packet goes through can change what PF thinks about that packet. So it may get passed or it may get blocked. But what changes it is the rule that matches the rule that is most specific to that packet. Okay? So the first thing we want to do is just this blocks all protocols, IPv4 and IPv6, any port numbers, source or destination, any IP addresses, source or destination, and any interface, whether it's coming into the interface or going out of the interface. It's just blocking everything. So if we don't add anything else, it won't be very helpful. First thing is pass in on the LAN interface from the LAN network again to any destination, and then we want to say keep state. Now, keep state is that filtering the state of the connection. This remembers if this packet came in and it's going to this server, I'm going to keep state and expect the opposite traffic to come back, because then that would match and be let back through. But once we get the traffic into the firewall, you want to allow it to go out the WAN or whatever other interface if you add more in the future. So we want to pass out on the WAN from the LAN network to any, keep state. And the last thing we want to do is allow the firewall to talk. So we want to pass out on WAN from the WAN network to any, keep state. Now, I will say, this actually means if you're on the firewall and you try to ping a host on your LAN or something, it will actually be dropped. You can say self in there, pass out from self, but there's no, this is fine for what we need for the moment. All right, so what we're doing here is this. We're changing the source of traffic from our LAN network to the WAN public IP. We're starting out not trusting anything. We're blocking everything and not sending responses. Okay? What we're allowing is packets to come in on our LAN interface, but they have to be coming from our LAN network, okay? They can go anywhere, but they have to come from the LAN network. And anytime a packet matches pass, it starts a state in the state table, okay? So that starts state on our LAN side. Now, we want to allow that traffic out our WAN. This does the same thing, but it's routing out our WAN, okay? And along with the IP routing, that will allow it to move across to the other interface. But this starts another state on our WAN interface going out. This is the security and the statefulness of this. The last one allows the firewall to talk. You'll notice there's no pass-in rule on our WAN at all. So if a packet comes in from anybody else on the internet, etc., the block rule will start and say, okay, I'm blocking you. All right? That's what the first thing would do, and then it will go down. Does this packet match this? No, it's not our LAN network. It's not coming in our LAN interface. Well, no, it's still blocked, see? And then it says, hey, does it match this? Nope. Does it match this? No. So the last match rule will block. So no traffic will be able to come in on our WAN at all in this configuration. Okay? You can add so much to this. We could spend literally 2 days talking about everything that this can do. But for your firewall, that's all you need for the moment. So we're going to hold shift and save this same way. To test the file, do pfctl-nf /pf.conf. Oh, it's actually very good that happened. We didn't put the IPs on the interfaces yet, so let's do that. You can either reboot or do this, but we're going to use etc rc.d network restart, and that allows those IPs to go back on there. Okay, so if we look, we have those IPs now on those interfaces. Okay, so now we can actually check our file again. Okay, now if you don't want to reboot, there's two things you can do. We need to enable it first and then do pfctl f /pf.conf. Now that enables it and it loads our rules. So if we do pfctl-sr, you can see our 4 rules. Okay, and these are for quality service. You don't have to worry about those first 2 lines. But this is our block drop, and then our pass out rules and our pass in rules. Now it will reorder them, so don't think something is wrong, because it's not. But you can see our network got expanded and everything. The last thing to look at here is our SN. That's for our NAT. And this is our source NAT. It changes anything coming from the 192.168.10 network, okay, going to anywhere to the address of WM1. So that 192.168.0.25. All right. that is our main configuration. So at this point, you're good to reboot. Again, we put into the RCconf. That's what we put in there. Just to, make sure yours looks like that. Now you will hear something about SSH. I didn't do that for an important reason. I don't want you to accidentally have vulnerabilities because of that, because you may not know what you're doing exactly yet with it. So do go to their netbsd.org and find that out for yourself, though. The DHCP just verify yours matches. And the DHCP conf. Also verify in your sysctl conf that you got that at the bottom. Alright, one more thing, I guess, if you didn't want to reboot, you can do sysctlw net.init IP forwarding equals 1. And that enables the forwarding so you don't have to reboot. But with that, this is part 2 of 3 in our NetBSD Firewall series. In part 3, we're going to verify that everything is working. So, as always, I'm Tyler with T-Tech. I'll see you in part 3.